Fertilizer. Fertilizer are generally inorganic in origin and they supply one, more essential plant nutrients in large proportions. Classification of fertilizer. A. Straight fertilizer. Fertilizer which supply only one major plant nutrient, e.g. urea. B. Complex fertilizer. Fertilizer which supplies two or more of the primary nutrients, e.g. DAP. C. Mixed fertilizer. Are the products made by physical mixing two or more fertilizer, e.g. NPK. D. Complete fertilizer. Fertilizer having all three primary major nutrients, e.g. NPK. A. Low analysis fertilizer. Having less than 25% of the primary nutrient, e.g. SSP. F. High analysis fertilizer. Contains more than 25% of the total primary nutrient, e.g. urea. Fertilizer grade. Refers to the guaranteed analysis of its plant nutrients. It is minimum guarantee of the plant nutrient content in the terms of available N, P, and K, e.g. NPK, 19. Fertilizer ratio. Refers to the relative percentage of N, P to O5 and K to O. E.g. a ratio of 2:1. 1 means 80 kg N, 40 kg P2O5 and 40 kg K2O. Order of hygroscopic nature of fertilizer, decreasing. Ammonium nitrate greater than urea greater than ammonium sulfate greater than CAN. Acidic residual nature of fertilizer. Anhydrous ammonia greater than ammonium chloride greater than ammonium sulfate urea greater than ammonium nitrate, lowest. Order of basic residual nature of fertilizer. Calcium cyanamide greater than sodium nitrate greater than calcium phosphate greater than calcium nitrate. Equivalent acidity of fertilizer. Anhydrous ammonia, 148 mEq. 100 grams. Ammonium chloride, 128. Ammonium sulfate, 110. Urea, 84. DAP, 77. Ammonium nitrate, 60. Equivalent basicity of fertilizer. Sodium nitrate, 29. Calcium nitrate, 21. 1. Nitrogenous fertilizer. The ultimate source of nitrogen is atmosphere and immediate and important source of nitrogen is organic matter. Maximum consumption of N and P in the state, UP. Nitrate fertilizer, properties. Highly mobile in soil. Suitable for top dressing. Nitrate fertilizer are basic residual in nature. Leaching and denitrification loss high. Examples of nitrate fertilizer. Sodium nitrate, 16% N, good for acidic soils. Calcium nitrate, 15.5% Nu. Potassium nitrate, NO3, 13% N and 44% K2O. Ammonical fertilizer. Less leaching but readily soluble in soil. Suitable for waterlogged soils. Acidic residual nature. Volatilization and denitrification losses more. Examples of ammonical fertilizer. A. Ammonium sulfate, NH4SO4. Contains 20.6% N and 24.5% sulfur. Most suitable for paddy, tea, groundnut and sugarcane. B. Ammonium chloride, NH4Cl. It contains 25.5% N. Being acidic residual nature, it is extensively used in paddy. C. Both NH4 plus and NO3N fertilizer. I. Ammonium nitrate, NH4 plus, NO3. It contains 33% N, half of ammonium form and half nitrate. Highly hygroscopic nature. Explosive fertilizer. E. Calcium ammonium nitrate, CAN. Commonly known as Kishan Khad. It contains 26% N. Neutral in nature. D. Amide fertilizer. Two types. 1. Organic form. Urea, NH, CONH2. It is most commonly used N fertilizer in India. Cheapest source of nitrogen. Contains 46% N. It is hygroscopic, therefore produced in granular, pellet form. Acidic in residual. Continuous use of urea for several years results reduce soil pH. Neem-coated urea. Being slow release properties, it increase the nitrogen use efficiency. 2. Inorganic form. Calcium cyanamide. Contains 21% N. Neither import or nor manufactured in India. Analyzing process for determination of available nitrogen is alkaline permanganate method. Biret. It is formed by the combination of two molecules of urea during manufacturing of urea. Biret toxic to plants, hence, concentration in urea should not exceed 1.5%. When urea will be applied as foliar spray on crop canopy, the biret concentration should not exceed 0.25%. Nitrogen losses. A. Volatilization, non-biological loss of NH3+. When pH greater than 8, nitrogen is lost in the form of NH3 in alkaline medium. Volatilization increase in poor drainage, e.g. rice field. About 60% of nitrogen loss in India is due to volatilization. Hence in alkali soil the N application is raised at least by 25%. Gaseous losses of nitrogen, ammonia, are carried out by both volatilization and denitrification. B. Denitrification. Formation of N2 or loss of gaseous form of N by biological reduction of NO3 plus and NO2 are known as denitrification. Denitrifying bacteria, Pseudomonas and Bacillus. Denitrification and volatilization occurs rapid at higher pH. C. Leaching loss. Leaching or drainage loss mostly occurred in nitrate fertilizer. Mostly occurred in humid area. Nitrification inhibitors. It is used in non-nitrate fertilizer. Inhibitors decrease the activity of nitrifying bacteria. Examples are following. Thiourea, 36.8% N. Oxamide, 31% N. AM, pyrimidine. N-serve, nitropirin. Neem cake. Slow-release fertilizer. Nitrate fertilizer mostly used as slow release due to overcome the problem of leaching. The solubility of nitrogen fertilizer is reduced by two types of compounds. A. Synthesizing compound. Urea formaldehyde, urea form, 38 to 42% N. Isobutylidinediurea, IBDU, 32.2% nu. Crotonylidinediurea, CDU, 32.5% N. B. Coating barrier. Sulfur-coated urea. Neem-coated urea. Modified form, supergranules. GROMOR, trade name of urea and ammonium phosphate grade, 29-29-0. 2. Phosphate fertilizer. A. Water soluble. SSP, 16% P2O5, 19% Ca and 12% S. DSP, 32% P2O5. TSP, 46 to 48% P2O5. DAP complex, 18% N, 46% P2O5. DAP is applied below seed furrow. MAP, 11% N, 48% P2O5. Monoammonium phosphate is new grade P fertilizer. B. Citrate soluble P fertilizer. D-calcium phosphate, 33 to 40% P2O5. Basic slag, 14 to 18% P2O5. C. Citrate and water insoluble P fertilizer. Rock phosphate, 20 to 40% P2O5, it is used for acid soil reclamation. Raw bone meal, 20 to 25% P2O5. Steamed bone meal, 20 to 30% P2O5. Biosuper. It is form of organic fertilizer mostly in Australia. Biosuper rock phosphate plus sulfur plus S oxidizing bacteria, Thiobacillus. Conversion factor for P. Percent P2O5 equals percent P times 2.29. Percent P equals percent P2O5 by 0.43. Phosphorus extracted in soil by following methods. 1. Bray-No. 1. For acidic soil, pH 5.5 or less. E. Olsen method. 0.5 mNaco3 adjusted at pH 8.5 and used for alkaline and neutral soils. Potassic fertilizer. Highest use of potassic fertilizer in the state, Maharashtra. A. KCl, more. It is most common and cheap fertilizer among potassic fertilizer. It contains highest, 60% K2O, among all potassic fertilizer. also known as murate of potash, potassium chloride. This fertilizer is suitable for acidic and heavy soils but not for alkaline soils. It shouldn't be used in sugarcane, sugar beet, tobacco, tomato and potato because in sugar crops, accumulation of sugar is affected due to chloride ion present in the fertilizer. Higher content of chloride ion reduce burning quality of tobacco and interfere with starch content in Solanaceae crops. In these crops should be used K2SO4 and KNO3 instead KCl. B. K2SO4, potassium sulfate. Contains 48% K2O 17.5% S. C. NO3. Potassium nitrate or saltpeter or niter. It contains 44% K2O, 13% N. It is an excellent source of potassium and nitrogen and mainly used for fruit trees, tobacco and vegetables. Conversion values for K. %K equals %K2O times 0.83. %K2O equals %K times 1.2. Activity ratio. Measures of the intensity of labile K in the soil. It represents K that immediately available to crop roots. Arc equals activity K plus, divided by square root activity of Ca plus plus, Mg plus plus plus. K and Na is determined by flame photometer. Micronutrients. 1. Ferrous sulfate is the most commonly used fertilizer which is sprayed at 0.5% on the standing crops like groundnut, soybean etc. to control iron chlorosis. It contains 19% Fe. 2. Manganese sulfate is the most popular manganese fertilizer which contains 26% manganese. 3. Zinc sulfate contains 36% zinc is the most commonly used zinc fertilizer. It applied as both to soil, at 25 kg per hectare, and plant, 0.5% as spray. Zinc oxide, 78%, used as seed treatment. 4. Borax is the most commonly used for boron fertilizer which is white compound containing 11% boron. It is highly soluble in water, hence should be used as boron fritz. 5. Copper sulfate is commonly used for both spraying on plants and applying as soil. It contains 22.5% copper. 6. Ammonium molybdate, used as foliar spray. In pulses more is more important nutrient because it is constitute of leghemoglobin hence, can be used at 3 grams per kilogram seed of pulses, it contains 54% more. Gypsum, CaSO4. 2H2O. It contains 29.2% Ca and 18.6% sulfur. Agriculture grade gypsum 70%. In general case 250 kg per hectare gypsum used for sulfur and calcium requirement especially in onion, mustard, groundnut and pulse crops. In pulses formed indigestible protein in the deficiency of sulfur. In groundnut popping is caused by deficiency of calcium. For reclamation of alkali soil, gypsum is used at 800 kg per hectare. Methods of fertilizer application. A. Basal dose. Application of fertilizer, pesticide at the time of sowing. Phosphorus fertilizer applied at basal dose due to their slow release nature. B. Deep placement of fertilizer. In paddy only ammonium form, NH4+, incorporated in reduced zone to prevent leaching and volatilization losses. C. Starter dose. In legume and vegetable seedling at transplanting applied NPK at 1:1 ratio. D. Split doses of N fertilizer. To increase N efficiency, applied 2 split doses in most of cereals having crop duration 4 to 5 months. Applied 3 split doses for crop having duration more than 5 months. Suitability of fertilizer. Potassium sulfate is used where quality of crop is required because KCl reduce the quality of crops. For rice crop, ammonium sulfate is the best. In acidic soils, rock phosphate and SSP is used instead DAP. In saline and alkali soils ammonical fertilizer are not recommended because alkalization of ammonia takes place. Indian soils are universal deficient in nitrogen and zinc. Fertilizer grade indicate the percentage of plant nutrients in a fertilizer. Fertilizer ratio is the relative proportion of three major, NPK, plant nutrients. In waterlogged soils, ammonium sulfate is best suitable N fertilizer. Potassium chloride or muriate of potash is the most common and cheap fertilizer among potassic fertilizer. Potassic fertilizer is suitable for acidic and heavy soils but not for alkaline soils. Denitrifying bacteria Pseudomonas and Bacillus. Conversion of ammonium into nitrite in the presence of nitrosomonas. Conversion of nitrite to nitrate through Nitrobacter. Nitrogen percent in Thea, 36.8%. AM and N serve are nitrification inhibitors. In anaerobic soils, sulfates are reduced to hydrogen sulfide by the action of desulfovibro-bacteria. Elemental sulfur when applied to the soil is converted to sulfate by Thiobacillus spp.